If you've ever gotten frustrated trying to put ceiling-hosted or face-based light fixtures into your electrical Revit model, you should try out a non-hosted version. So today I'm going to show step-by-step how to create this non-hosted, recessed, troffer, or linear style light fixture. And not just the fixture, but also how to embed a scalable symbol that even includes an emergency on or off type of graphic. So if that interests you, stick around and let's get right into it. So I'm in Revit 2022, which is the version that I still create families and my template from so that it works with everything from version 2022 on up. So I'm going to start a new family. So go to new, and I need to choose my template. This is very important to choose the right template for my family. Since we're creating a light fixture, let's go to English Imperial. I'm here in the US. So we're going to go to a light fixture, a lighting fixture. Now there's a ceiling based, there's a wall based, and we're trying to get away from any kind of based fixture or hosted fixture. So we're going to choose lighting fixture. Now you'll see that this template has a light source built into it. And that's what this yellow thing is. It's kind of hard to see, but there's a yellow light source. And if we look at the 3D view, let me go to 3D view, and I like to rename this as 3D view. And then we can click up here at this little box to change views. It's really kind of just a sphere. And we can change its look. And so instead of the sphere, I'm going to change it to this half dome. You can also change shapes. You know, if we're doing some kind of a linear type of recessed fixture, we may want this type of shape. Personally, I don't use Revit for lighting calcs because it's just kind of an area zonal cavity method, and I prefer using a third-party point by point. But it still makes sense to go ahead and throw this light source in there. So in case you do want to try to do that, it's in there. So let's say OK on that. That gives us the size. And then the size is kind of huge. So I like to change its symbol size. Now I can't change it here. It's grayed out because it is actually a family parameter, which you get to here. And so here we can go to light source symbol size. And I'm just going to make that something very small, like 2 inches. And that's just a symbol. Now, one thing is that is a three-dimensional symbol. And when you bring this fixture into your model, this can actually get in the way of other things. So you don't want it too big. Go back to our reference level. And this is a top view. And so I like to call this top view. It helps when we're navigating. So this is a top view of our light fixture. I've shown you here on the screen the kind of light fixtures we're looking at, whether it's a 2x4 or 2x2 recessed troffer style panel, LED panel fixture, or whether it's maybe a 4-inch wide by 8-foot long linear recessed. This family will work for any of those. And we're going to make it parametric so that we can change its dimensions in our actual model. We're going to let this intersection here be the center of our light fixture. And so I'm going to start off with this just a simple rectangular family. A lot of our electrical families are very simple shapes. We don't need to get super complex in the geometry. It just bogs down our model, frankly. We just want enough so that we can represent it in space in our model if we want to do any kind of interference checks and things like that. So we're going to start off by drawing a rectangle. And the way we do that is creating, just like these dashed lines, if you click on these are reference planes. But we use these to help form a skeleton from which we can add geometry in the form of extrusions or blends, revolves, different kinds of shapes, 3D shapes. So if you've ever used something like SolidWorks or Blender, you're familiar with these 3D shapes that you can use. So that we can kind of do that here in Revit. So what we're going to do is create a skeleton of these reference planes, and there's also reference lines, therefore a different kind of boundary, like a circle or maybe a slanted object, which we're not doing here. So we're going to use reference planes. Again, we're on the top view, so these would be the long sides of our light fixture, and I drew this wrong. We need to make sure that we do this exactly parallel. And you can tell if I get off of parallel, I get this angle. There we go. And their length doesn't matter. They actually extend forever in either direction, logically behind the scenes, even if you can't see it. So let's go reference plane this way and this way. Again, we want that 90 degrees. So now we have a rectangular shape. Now to control this shape, we want to add some dimensions. So up top, we can get to aligned dimensions. You can even go to annotate and get to all of the different dimensions. But even if you just click on a line dimension, then it gives you the dimension tool up here, and you can pick different kinds. We're going to do aligned. We're going to put a dimension from this line to the center point to the other line, and I'll show you why. We do that, and then there's a little EQ up here that's slashed out. We want to hit that EQ to unslash it. So now we've made these two lines equal distance from the center line, which in effect centers our light fixture, at least left and right. And then we also want to add another dimension just between the outer lines, and to actually add a dimension. We can click on this and type in a certain distance, like 4 feet. But we want this to be variable when we bring this family into our model. So we need to turn this dimension into a label that has a parameter. So the label is none here. We want to actually create a parameter, and this will be a family parameter. It's part of this family. We're going to call this fixture length. Now, there's type and instance. A type means that every light fixture of this type, let's say we're going to call it type A. Every fixture of type A will have the same length. That's how light fixture types typically work. So we want to leave it as a type parameter. And it's going to be grouping under dimensions. And that just means that when you click on the family types to see the family parameters, it gets grouped under one of these headings: constraints, electrical, lighting, electrical loads, dimensions. So our fixture length is under dimensions along with the light source symbol size. So we're going to give this a starting dimension of 4 feet, and you can just hit 4, enter. So that's our first dimension. Now the other dimension we want is this fixture width, we can call it. Again, we're looking at the top of the light fixture. Let's do that again. We're going to first set it to be equal so that it's centered. Click anywhere, hit the EQ. Now these lines are equal, and you can see how this works. So I move one, they both move to keep it centered. So that's the purpose of that. And then let's go ahead and click this here and here, and let's give it another label and a parameter for that label called fixture width. Simple as that. It's type, and it's under dimensions. And then we want to give that, let's start with a dimension of something like 2 feet. We're starting with kind of a 2x4 old school troffer or LED panel. So there we go. We have our main lines we need. And then we can extend these out if we want them to look complete. It's not critical. And let's get these dimensions out of the way. We can also change the scale. Right now we're at 1/2 inch. We can change it to 1 inch to the foot to scale the annotative dimensions. And we'll extend this out. Now that we have this skeleton, if you will, we want to test our dimensions, test our labels, test the parameters, test everything. We've already kind of seen that this stays centered, so that's a good flex or test. Same thing here. We can also type in some values here and try 3 foot by 1 foot, and let's see if things moved appropriately, 3 foot, 1 foot. So everything looks good here. Now what we can do is we want to draw some 3-dimensional geometry for this light if we're doing 3D models. Now I have a whole video that I'll link in the description below that shows that you don't have to do 3D if you don't need it. If you're just using Revit right now in place of CAD and you're using CAD, you don't have to have 3D objects. I personally suggest that you get there because the 3D aspects of Revit are very powerful, and you'll find that many clients request that 3D level of coordination. But if you're just starting out or you just need basic 2D drawings, you're fine. You don't have to do this. And you can actually skip ahead into the annotative symbol part of this. Anyway, we're going to do a full 3D model, even if it's basic, as well as 2-dimensional symbol. So the 3D aspect of this is we're going to go to create, and we're going to do a simple extrusion. And you can see this little animation pops up below if you hold it there. That shows a shape that gets extruded or stretched up in this case. So we are going to draw a rectangle and just stretch it up or down to create a simple rectangle. So let's hit extrusion, and it's asking for us to sketch this extrusion right now. We're kind of in an edit or sketch mode, and things dim away. So we can use these tools, draw tools, lines, rectangles. There's different shapes, arcs. We can even pick lines if we want to pick some of these existing lines to form a shape. But I'm going to simply do a rectangle. And I'm going to actually start it right on the corner and hit the other corner. You can also just start it outside the boundaries that you want to show how you can use the align tool. Once you draw this, we don't finish yet. Let's go ahead and align these edges of the extrusion to our skeleton that we drew. We're going to align them and then we're going to lock them so that when we move these reference planes, the extrusion edges move with it. And that's how we're going to control the size of this light fixture. So up here we have an align tool. It aligns one or more elements with a selected element. So we're going to align to this. So we hit our target first. We're going to go to this line from that line, and then we want to use a little padlock and padlock it. And we're still in the align tool, so we can go to there, from there, align it. To there, from there, I'm sorry, not align it, let's lock it. And then to there, from there, lock it. Now we've locked and we can finish this. Now what we have to do, we're in the align tool, so we need to go back to the modify create tool so we can get to our finish edit mode. Hit that. Now we've created an extrusion. And just up here, this thing called depth up here, there's a default of 1 foot for depth, you know, how far into the screen or out of the screen that extrusion extends. And the default 1 foot is fine because we can stretch it and tie it to another dimension here next. So now we have that done. Now, if I try to just move the edges of this extrusion, we get an error down here. Constraints are not satisfied. Well, what does that mean? Let's see if we can expand this. And then you get this crazy error message that's a lot of times hard to figure out. But it's saying we got reference planes and constraints, linear dimensions, and that's what's going on here. All it's saying is that this extrusion is locked to these dimensioned reference planes, and I can't just move it by itself. I can move this, and then the extrusion follows. So see how that works? These guys actually control the shape of the extrusion because the extrusion is locked. And look at 3D view, we can see what we have here. Now, our light source is way up here, and we've got some vertical issues. We're going to deal with that third dimension now. So let's go to a front view, and it's already started here. Front view. So what do we have in the front view? First of all, you'll notice we have our light source way up here, and it's actually attached to a reference plane that's called light source elevation. We can move this around. So we want our light source now to actually be below our fixture. So we can move it down here, and we'll apply some dimensions to that in a minute. Also notice there's a thing called reference level. This will end up being the elevation of our light fixture in the model. So when we say put it at 8 feet, because we have an 8-foot ceiling, this is the part that goes at 8 feet. Therefore, we have to decide what part of the light fixture do we want to be at this elevation. Well, we want the bottom of our light fixture, the lens of the fixture, to be here. So the body of the fixture goes up into the ceiling. So this is drawn correctly. Now we're going to be doing some dimensions and tying it to some reference planes, and this reference level is on top of a reference plane. If you hit tab, you can tab down to that, which ends up being a reference plane. And so when things are stacked, you can use tab to cycle through the stacked items. So instead of doing that, I'm going to move this reference plane out of the way, and I can just drag it over. As long as I don't move it off of its plane, I can just drag it over. Another thing I can do is click on it and use my arrow keys to do a little bit of a nudge, and then hold the shift down and arrow key and do a big nudge. So I'm getting that out of the way. Hit escape. Now my reference level, again, it's extending forever in either direction, but graphically it's out of my way. Now I can get to this reference plane. So now I need a reference plane to define the top of my light fixture body. So let's go up to create, and I can do reference plane. I could also just right click on this and say, so create similar, and then draw a reference plane. I kind of like to line them up. It doesn't really matter. Just graphically, it helps me to line these up. Now I want to dimension this height. So, like we did before, use a aligned dimension. Start down here and work up to here, and then click off of it. And there's no centering to be done in this case, so this is all we need. And then we can click on this, and again, we want to add a label that has a parameter. So we're going to call this fixture, we can call it depth or height. Let's call it height. And again, it's a type. It's going to be all type A's are going to be the same height. And it's under dimensions group parameter. So now we have, if you look here, we have our 3 dimensions, height, length, and width, that we can control, and we can test the height, make sure it's working by typing in 3 feet, and there it goes. Now, our extrusion didn't go with it because we've not locked it to that reference plane yet. So we need to do that. Now, again, we can use the align command. The other way you can do it is to click on it. We can drag it. Now, it lets us drag it this time without an error because it's not locked yet. We can drag this with that arrow and get right on top of that line. And once it's on top, then we are presented with the lock. So we can lock it. Now it is controlled by this reference plane, which is what we want. So now we can control the height of the fixture. So in 3D, we've got ourselves a beautiful box, and our source is underneath it so that it will shine down onto the floor or whatever's below this light fixture. Back to the front. Now I want to control where this light source is relative to the bottom of the fixture. So I simply am going to apply a dimension. And let's apply a dimension from here to here. And instead of having a label with a parameter for this, it's not something I really need to change in my actual electrical model. I'll just set it here. So you can't just click here and change it. What you have to do is you have to click on the reference plane associated with that dimension. Then you can click on the dimension. So it's a little tricky in what you can do. And let's just change this to something like 2 inches. 2 inches won't matter a lot as far as lighting calcs if you end up using this light source for doing area-based lighting calcs. And then we want to lock that dimension at 2 inches. And we can just padlock it right there. Like I say, there's no label, no parameter. It's just forced to be 2 inches. So now we have our 3D view. Simple as that. We can change down here how it looks. Right now we're doing a hidden line. We can do shaded. And now's a good time that we can keep our architects somewhat happy by adding a material parameter to this extrusion. We need to apply a material parameter because there's no parameter in our model yet called material. This extrusion is kind of like nested into our family. And so we need to take its material, right here is a material parameter, and we need to associate the nested extrusion parameter to a family parameter. We need to map it or associate it. So far right, the little button right there, associate family parameter. Click on that, and then we have the opportunity to associate that with a family parameter. Now we have no family parameters that are applicable to the material, so we're going to have to create one. And then down here is the create button for this parameter. And so like we did before, we're going to call this material. We want every type A light fixture to be the same material. If we have 100 of them in our model, we don't have to pick each one and change them. Do it by type. Now this time, it puts it under a group parameter called materials and finishes, which is appropriate. So I kind of like to call it something like light material for a lighting, just to help it stand out that what material are we talking about? And say, okay. And then again, up here under family types, under materials and finishes, there we go, light material. That way you can change the look of it in your 3D presentation or sections if you really want to. Okay, so now we have the 3D aspect of this done. Now, what would this look like if I brought it into a project or a model? So I want to save this family first. So I'm going to File, Save As, and save it as family. And I've already got one in here, ER Light Recess Troffer. I like to label it NH for non-hosted and R22 for what version it is. Option 1 backup, okay. And then I have a project started from my electrical template. I'll link the description below how I created the template that has some basic ceiling plans and floor plans and some basic families brought in and some settings all done. But I linked in an architectural model. This happens to be an architectural model that Autodesk provides. You can download it from their sample projects if you want to work with it. But here's a lighting plan for this. I'm going to bring my model in. If I go back to my 3D view, I can just say load into project, and my light fixture will load in here. Now let's go find it. And recess troffer right here in H, drag it in, and I can place this. Now, I'm trying to place it at 0 feet right now, which is on the floor, and I'm not going to be able to see it because my view range is set up with a cut plane like around 4 feet, so I have to be above that. So let's say I'm going to bring it in at 8 feet. And I'm going to put it in this ceiling here. One note here is that when you're using non-hosted fixtures, it doesn't automatically find your ceiling. It just brings it in at whatever height you say. So if I want it to be right here, I need to know what height that ceiling's at. I can cut a section and look there, but I can also go up here to annotate, and there's this thing called spot elevation. If I click on that and hover, it'll tell me exactly where that ceiling is. So you can see this is kind of an odd height. It's not nice and even 8 feet. It's 8'6" and 3/8 of an inch. So click it once and click it again, take two clicks. And I want this fixture to be at the same height. Again, this is one drawback to non-hosted is I have to manually tell it what height I want this to be at. So I'm going to go 8'6". I'm going to get close enough. 8'6". And we can go ahead and drop in this section just to take a look at this room and double click on the head. And we can see here's our fixture. So that gets it approximately the right location. The lines you see are really just the boundary of the extrusion that we drew, which actually works fine for a light fixture like this if you're fine with this kind of symbol. Now, our firm uses a different symbol for a recessed light fixture. We have a box, but we have a diagonal line through it. And then furthermore, if we want that to be an emergency light, we fill in half of that fixture at the diagonal line. So many times you don't just want the extrusion of your light to be the symbol. You need a symbol in addition to that. So that's what we're going to get into next, is how to draw a symbol. And there's a couple different kinds of symbols. So I'll show you a couple different ways that you can add some symbology to this light fixture. I also wanted to note that this light fixture is scaled with the model. If I change the scale, and let me get out of this view template so I can play with the scale directly. If I change the scale from 1/8 inch to 1/4 inch, it stays the same size. It's still it's still 8 feet long. Now contrast that with something like a power plan. Let me go to the power plan, and in that same room, I'm going to bring in a duplex receptacle. So up here, a standard duplex receptacle. And this happens to be non-hosted as well, which is nice. I don't have to worry about finding a wall. But I'll put it on this wall anyway, and it kind of snaps there. So I'm going to put it on this wall. Now, this symbol is an annotative symbol. It always stays 1/8 of an inch, and no matter what scale I make the actual drawing. So I was to change this to, and again, let me take it out of the view template so that I can change it here. 1/4 inch. Now, it looks like this symbol got smaller, and it kind of did, except the floor plan got larger in reality. So if this was on a sheet, this floor plane would take up much more room. But the symbol, if you measure it on the sheet, is still an 1/8 inch circle. So this symbol changes relative size depending on what scale I'm at. If I'm at 16th inch, then that symbol looks huge. because the floor plan is small. Again, that's the difference between an annotative symbol versus what I call a scaled symbol, which stays the same, like the doors and windows. It stays the same size in the model, and it'll shrink or get larger with the actual model. So I'm going to jump in here and show you a couple ways to add some symbology to this light fixture. So let's go back into our family. Going back here to the top view. But what I'm going to do now is I'm going to let the extrusion be the outside boundary, but I need a diagonal line to supplement that. So what I can go up here, now there's a couple things. I can go to create, I could do a model line. Now a model line, the model part means it's going to show up in the 3D model as if it's an actual 3D object in the model. In a 3D view, I don't need the light fixture to have a slash line on it. If I look at the ceiling, I don't want to see a slash line. This is only a symbol. So I need to go instead to the annotate and make an annotative line, a symbolic line. So click symbolic line, and by default, it's going to be classified under the lighting fixture category. So if I change the line type width, or if I change the color of the lighting fixture category, this line will change also. And I can use my tool for a slash, and let's just go with a slash from here down to here. Now, will that appropriately move with my dimensions? Let's see. It does. Lines have a property where they automatically stick to whatever you attach them to. So even if we move this way, that line will stick. So we're good. We don't need to constrain it with padlocks. Let's save that and then bring that back into the family and see how it looks differently. Let's overwrite the existing one. Now we have our slash. That looks more like my recessed fixture symbol. So that's one way you can do it. I like one more piece of graphics in my recessed light fixture. I like to be able to shade this. Let's go back to that family and see how can we shade it. So go back to the top view of the family. If I go to annotate, I can go to a masking region, but I'm not looking for masking. I'm looking for a filled region. I don't have that option. Now I must say that finally in REVIT 2025, the newest version out as of this recording, you can add a filled region into an actual 3D family. So that is beneficial. But if you're in anything before 2025, we have to do it a different way. We have to create a separate symbol and then nest that symbol into this family. How do we do that? Let's go to File New. We're going to do another new family. Now this time, back to English, we have a couple choices. We can go into annotations and make it an annotative element, like that receptacle. That was annotative so that it was always the same paper size no matter what I did. I don't want that for this light fixture because I want it to stretch with the light fixture size. So what I have to use is a thing called a detail item. This is kind of a complicated part of adding symbols to certain families. When you want the symbol to stretch with the light fixture, it has to be a detail item. So let's go to detail item. A detail item has model dimensions, not paper dimensions. So here we are. It's similar to the other one, and we have a top view. We need to make a symbol for that light fixture that is the rectangle with the slash and a filled in region. So we need to do our reference planes again. We're pretty much recreating what we just did. Like I say, luckily REVIT 2025 has addressed this issue, so we don't have to jump through this hoop. But if you're like us, we have to follow along with our architect client and use the version they're using, and they're still using 22, 23, 24. So let's go through and redo what we just did. We have to do a center. We want to do an actual dimension. We want to give it call this length. Now, because this is going to be nested within our family, we have to make it instance. It's just the way it works, and it can be under dimensions. and then do the same thing for the width. Let's center it, and then actually dimension it. Call this one width, and it has to be an instance because it's going to be nested. And that's all we need. This is only a two-dimensional symbol, so I don't need a height. But I need some graphics now. So let's go into Create. Now, Create works here because we're not in a model. Again, it's a difference when you're in this detail line versus an annotative. So we want a line, and we can use the rectangle. So we are just reproducing our light fixture. We want to lock it. Okay. And then we want to get that slash in there. So create line. And let's give it a slash. And it locks automatically, as you'll see, just like the other one did. So we've kind of repeated what we have in our other family, but now we need to add this filled in region. So how do we do that? Create, up here, filled region. There we go. We have that available. Filled region. Now it gives you a default pattern for this filled region, and it's called concrete block. We want to change that to be solid fill black. And then we want to use this pick lines. So we don't have to redraw the lines. We can just pick the lines that are already in our family, use those as the boundary. And we want to lock them in so that it stretches. And okay, there it filled it in. Now that should stretch, and it does. Okay, so we're good there. We flexed it. Now, one more thing I'd like to do is I want this filled in region. This is only for an emergency light fixture. If I click on this, I get detailed item filled region. There we go. I got the filled region. Now, the visibility, visible or not, I want to tie this to a family parameter called emergency so that I can turn this on or off in my actual model. So again, map it or associate the family parameter. We need to create one. And I'm just going to call this emergency. Again, this is going to be nested into my family, so I need to make it an instance parameter. And I'm going to put this under graphics. Okay, so now I have visibility control on or off as a family parameter in here, emergency. And the default right now I have is on. I'm going to make the default off. And it doesn't show it here, but it will when I nest it. So let's save this. So we're a couple levels deep here. We're going to save this one as, and I'm going to call this symbol, emergency for a troffer. It's a rectangular emergency because I have a circle that's emergency for other fixtures. Save that. And then I want to load it into my project and close it. So I'm going to load it. Now what project? I don't want it in the project. I want it in the actual family of my troffer. Okay. I brought it in and it's large. Escape. So what I want to do now, and because this is a detail item, I can actually move it around. I want to pin this. I want to lock this symbol to my dimensions of my extrusion. So I want to lock it to these reference planes. Now I want to force this symbol to be the same size as my extrusion. The way I do that is I click on it and I can get to my dimensions. I want to associate these dimensions with the dimensions I have set up in this family. So I'm going to go to associate family parameter, or I'm mapping them. Click on that, and I want the length to be the same as the fixture length. And I already have fixture length defined. We've already made that. So I want to associate that. Now you can see it pops down to the right length. I also want the width to be the same as the fixture width. So the width of my symbol here, width, I want to associate it with the fixture width. Now you can see why I named it the way I did. So those are the same widths. And as I change this model, those change also, but they're not quite lined up. So I need to drag this symbol on top of the extrusion. And when I do that, I'm presented with some padlocks to lock it vertically and horizontally at that center point. So that's what I will do. So now, as I change the size of my fixture, the symbol changes as well. And I don't need that line that I drew in here. So if I tab over it, I can get to that line and I can delete it. So now I deleted that. So now I'm letting this symbol do the talking. However, the extrusion will still show up. So what I need to do is in 3D view, it's easy to get to. Now I want to tell the extrusion not to show up in a plan view. Extrusion is fine in 3D or in sections and elevations. So the way I fix that is I select my extrusion, I go over here to the visibility graphics overrides and hit edit. Now I can decide the family element visibility settings. So what it's saying is display this extrusion in 3D views and plans or reflected ceiling plans. No, I do not want to see the extrusion in the plan. I want to let the symbol show up. And so I'm hiding the extrusion in the plan. Now I want front and back, elevations, left and right, I want that to show up. Any detail level of sections or 3D views is fine. All I've done is said, extrusion, I don't want you showing up in a plan view. So save that again. Load it into the project. Overwrite the existing. So there. Now it looks pretty thin. Why is that? Well, because now instead of using the lighting fixture line type settings, it's using the detail item line type. So now we need to go up to our object styles here and go down to, it is a 3D element, down to a detail items, and you'll see that it's only set up for a line weight of 1. Let's bump that up to 4. Okay, and now that pops out. So now it's a different category. And just so you know, the receptacle itself is also a different category. This is typically a generic annotation unless we set it to our own separate line style like E annotation or something like that. So there's a lot of different settings for these weights and it can get confusing. So we just have to keep in mind what category is that symbol in so we can change things like colors and line weights. Let's test out the emergency button. Now, if I look over here, I don't see an emergency button. Well, what happened? I did not map that or associate that emergency in the family. So let's go back to the family, top view, click on this, and I have my emergency. I need to, over here, associate it or map it to a family parameter called emergency. So I need to make an emergency. Again, because it's nested. It's nested in this family. So I'm going to put this under graphics and I'm going to make it an instance because some of my A fixtures might be on emergency generator, some might not. So I want that control to be at each light fixture that's in my model. So it's an instance parameter. And then of course the most important thing to do is to get our electrical connector in here so we can hook it up to a circuit. So in our Create tab, go over to Electrical Connector right here. And by default, it wants to be placed on a face of geometry. And so you can do that, or I like to pick a work plane and then select a work plane, and just the reference level works fine for that. Say, okay. And then it places it right in the center of my fixture on the work plane. And then I need to take the electrical connector and get it ready to be mapped into this family. So we need to make sure it's not a communication type, but we want to go to a power. And because this is a load, not a distribution, we want it balanced. What we actually want to map into this family so that we can get to it in our model are the voltage. And let's give it a 120 volt default. We're going to associate this with a family parameter. And we need to create a voltage. So we'll go fixture voltage, and this is a type parameter. All type A's are the same voltage. And let's put it under electrical group parameter. And then we also want the number of poles, and this is going to be fixture poles. Also a type parameter, and let's put it under electrical. And then I want the load classification available to the end user so they can change it to interior lighting, exterior lighting, general lighting, whatever kind of classification they would like. So we'll call this fixture load classification. Also type, and put it under electrical so they're all grouped together. And then also we need the load. And let's give it a 30 VA default, which can always be changed. And we already have a parent load in this family that we need to assign it to. It's built into a light fixture. So now if we go up to check these out, we have load class, poles, voltage. Now this lamp and wattage are just text. They're just comments. And then our parent load is under electrical loads. So that looks good to me. So we are good to go there. And let's save that and bring that into the project. And this should turn out over at existing. Now I can get to this. There, it shows up because I mapped it or associated it. Click on emergency, and it fills in half the fixture diagonally. So that is how you get a symbol onto your 3D light fixture. And this ends up being a scaled symbol versus an annotative symbol. Now, if you like this kind of family editing, take a look at this next video that I have on the screen to see how to do even more non-hosted families. And thanks for watching.